In this lecture, we're going to talk about multi-threading. So multi-threading is going to be based upon the principle that we want to take a program and break it down into a set of tasks that can be executed independently of other parts of the program, therefore independently of other tasks. We're then going to use threads as the mechanism that is going to enable us to run a task on the CPU. Therefore, very importantly, a thread is going to be the flow of execution from the beginning of the task all the way to the end. It is also going to store all the state data for that particular task. So when we think about normal programs that you've been coding, you'd normally run the program sequentially. You'd start your program, execute one thing, wait for the return, do the next thing, wait for the return, do the next thing, the program is over. When it comes to multi-threading, we want to design the program in such a way that we can break it up into a set of tasks that can be executed independently of one another. This gives us a form of concurrency. So we can do something and something and something else entirely all at once using different threads on the CPU for the computer. So if we have lots of threads or lots of a multi-threaded enabled CPU, we can then execute multiple tasks simultaneously and hopefully gain some efficiency by doing so, having our program execute the different parts of the different tasks concurrently and then end our program hopefully much faster than doing it sequentially. Now, if you think about it, multi-threading enables us to perform tasks in a non-sequential order. So multi-threading, therefore, is a programming paradigm that would be enabled by a multi-threaded CPU. The central processing unit of the computer requires that we have the capability to run multiple threads. If it can run multiple threads, we can then break our program down into multiple different tasks and run those tasks on the threads of the CPU. Remember that the CPU only has a finite number of processing cores, therefore can only run a finite number of threads. Technologies such as hyperthreading enable the swapping out of threads much faster. Because remember, threads need to share time on the CPU. Therefore, you cannot run every thread at once. They will all need to spend a bit of time on the CPU before being rescheduled. Now, in Java, in order for you to have a task that can be run on a thread, it must implement the runnable interface. So runnable will then provide us with the run method where we put all the logic that we want to execute. Now, in order for us to then utilize that task that we created, we need to create a thread and load a task onto the thread and then start the task. This means the thread that is going to run the task can now be scheduled to run on the CPU. So I provided an example to you guys where we created a printchar and a printnum class that are then responsible for printing out a number of characters and a number of numbers respectively. And then I provided you with an example that we could run all of these on threads and would note that the output would always be different. Please refer back to the video on multi-threading to see the output and to see a more in-depth discussion of how this all works.